Great. Well, welcome everyone to the first Cairo Research Computing and Data seminar. I sent around links for a couple Python tips and tricks. And so I thought instead of going through like the entire list, because that would take the entire time and I'm not sure it's going to be super useful, I thought we would I have some questions. And I thought we could just pick out some of the ones that we all felt were kind of cool and we might be using ourselves and we really think other people should know about them. So I got a list of questions, and then this will be very participatory. And I kind of want to keep that same kind of vibe going forward, is not to make this about like someone speaking at somebody, but we've all read it. We all kind of, or at least browsed it. We all kind of know what's in there. And so let's just kind of like chat about it. So I got some questions and I'll do my answer first and I'll kind of open the floor and we'll see how this works. So the first kind of discussion point I thought, and Scott and Noah are kind of stole my thunder already because we came up with the same questions. I thought that was really good. So, anyways, the first one was like, so which one of the ones on this list of 27, there's some overlap, did you find the most useful? Do you use the most? And so I have three that I think are awesome and that we should all be using. So the first one's really basic, and that's F strings. And so I only saw the F string one, but that was the one where you can say print and then put an F in front of it and a single quote. And then you can put like not just text in there that's going to actually print, but also in curly brackets, you can put like expressions and variable names and things. And so it's a really quick and simple way to kind of print out like debugging output or very simple messages and have it interpret and decode like the variable names or even like simple functions or expressions in those brackets as well. And so I thought it was super cool. Should I maybe I should share my screen and kind of put some of these up on the screen so we're all looking at the same thing. Let me do that quick. Let's see. I'll get these in another window. Uh,
I did like the caveat on that, basically we're saying, I'm going to execute whatever's in this string variable. It's like, well, you better make sure you know what's in that string variable before it, becomes another little Johnny drop tables
right.
problem.
Right. Yeah, so it does execute. So if you actually like assign something in there or whatever, it actually does it. So you normally don't want to do like assignments. You just normally want to put like a variable name or like a variable name dot to uppercase or something to like format that name in some way. But yeah, this is the F string I was talking about. So we use these all the time on our team. And so this is new in Python 3. In Python 2, you used to do this with like dot format. And so this is the new like
Yeah.
dot format method in Python 3 for those people that have been in Python a while. But we use these all the time. I really like these. I think this is a great one and gets a ton of use out of. The second one I wanted to bring up that I really like is Lambda functions. So I also use these all the time. And so oftentimes there's like these functions or Python keywords like sorted or there's a lot in pandas too where you can like filter on a function or apply a function to everything in there. And instead of actually going out and defining a function with a certain name, you can just like quick define a function right in the call as you're typing. So Lambda is basically says, I'm going to define a function. It doesn't have a name because it's only going to exist on this one line of code. But here's all my parameters for the function, and this is what the function does. So like this Lambda function is an unnamed function that takes in an x and does a length on that x and returns that variable, and that's what this key is getting assigned to. And you can make these as complex as you want, but they kind of have to fit in like one line of code. So you can like, string together like a bunch of different operators with like dots, like two uppercase, and then like grab the like last character of a string or anything like that. But they're super useful because you don't really have to like go out and define them somewhere else. You can just quickly define it in your line of code and then and then use it. So I like using these. Sometimes my Lambda functions end up like, oh, this one was really useful. I'm going to use it again somewhere else. And then I'll go and like turn my Lambda into an actual function, give it a name, and then you can just put the function name there. But like as I'm just writing code like in a Jupyter notebook or really quickly, I like using these a lot. They're nice and quick and easy. And then the last one that I wanted to point out that I use all the time, much to I think Scott's chagrin, is list comprehension. I freaking love list comprehension. And I like it because you can do a lot of stuff in like a single line of code and it's really, really concise. So this article talks about list comprehensions, but this one actually goes into the fact that like you can do a bunch of different things in comprehension. So lists I use a lot and also like dictionaries. But I like this example better. It's a little simpler. So I'm going to talk about this one. So like in Python, you can do these comprehensions and you can basically create a list or a dictionary in like one line of code from another list or iterator. So like here's a range of numbers from 0 to 9. And I'm going to go through that list of 0 to 9 for all the x's. And I'm going to assign this new list that takes and does a square of all of the numbers in that range. And so just with this part, this is like that's super useful just on its own because you can basically take and modify what you have in a list in a certain way and reassign it to a new list. But the one thing that's really cool is you can use this if statement on the end. So you can do it and filter what's in that original list to a certain condition. So like in this case, it's only going to take, that's mod, it's only going to take the even numbers. So it's going to take this range of 0 to 9, only take the even numbers, and square them all. And so this is a really easy way to like kind of filter on a list and assign it to a new one. Or if you have like two different lists and you want to smash them into like one dictionary, you can use the curly brackets to do a dictionary. Is there an example in this one? Yeah, it's like for a dictionary, you just use the colon to separate the two pieces, the key and the value of the dictionary. And you can loop through a range or even a second list and kind of use those to assign and create your new dictionary kind of on the fly without a for loop. So these are super handy and they're very Pythonic, as they would say. It's concise and kind of easy to follow after you get used to them. I love these things, and Scott always gives me crap about making them a little bit more complex than they need to be. But yeah, I like
just
these a lot.
it can be hard if you want to intercept something between two steps in a chain.
Exactly.
You got to bust the line to do something.
Yep. So those are my three. What about other folks? Like raise your hand or just speak up. What were your favorite ones on the list that you use all the time?
I'm definitely a dictionary fan. Keys and values and or keys with duplets with many values or structures as the value.
I would say mine are probably similar to yours, but another one that I have found myself using recently is generators for like big data sets, working with LSTMs when you need to generate sequences. It just gets too large to store if you just store them all locally. So I've been using generators as well.
Great. Yeah.
And I was going to mention enumerate is a really helpful function if you're sort of iterating through a complex data set or lists. And with enumerate, you can kind of keep track of the index as well, if you, which can be useful. So you can basically, if you have a list, you enumerate, you'll wrap the function or the list in enumerate or pass it to that function. And then similar to the example Pat has on the screen for index name, you have like, okay, at position 0, position 1, here's the value of that element, which is kind of, it's helpful if you're trying to diagnose or understand a data set a little better. Be useful.
Yeah, so this example doesn't show the output, but what you'll get here, Noah, if I'm correct, right, is that you'll get three lines of output: 0,
Yep.
Alice; 1, Bob; 3, Charlie. And it'll just keep going with increasing that index as you go. Yeah.
Anyway, so that's okay.
And we talked about the difference between number 19, deep copy versus shallow copy, because I will use like if I'm transforming a data frame or something, I always just use dot copy.
Mhm.
But is that correct? Should I be using a deep copy instead?
Yeah. Let's save that question. My third question is about things we want to explore more. So let's save that one, Harrison. Is that okay? That was Harrison, right?
Yes and yes.
Oh, okay. Yeah. Remember that question for about 10 minutes. Any other ones that people really like saw in here that they use a lot and they think like everyone else should know about them?
Oh, one that I use a lot with enumerate is zip. Zip is very
Yes.
helpful. You can think of it as literally like if you have two lists, it's kind of like zipping them together. And then you can enumerate them at once in one for loop. So it's really great for like parallel enumeration, especially, and with index, it's really helpful for like, say, if you have two data sets that are pretty similar, but you want to like go through it element wise and compare the differences, then you could zip those two lists or those two intervals. So depending on what your data looks like, you probably be able to zip it. And then, yeah, it's basically like lining them up. Look at compare the first element and each interval. So it's a pretty helpful function. It's also good for combining lists or tuples. Like say, and a lot of the work we've done, like we use tuples, and if you want to sort of, I think of it visually, like if I have a list of tuples, but I want to like line those tuples up and then split them down the middle. So I have one list that's just the first element in each tuple and another list that's like the second element in each tuple. And zip is really good for that.
Well, so like Noah, for this piece of code, so what would the output be on this piece of code, just to give folks an idea?
Yeah. So Alice and 85. So yeah, you're basically, if you imagine it's like you're stacking basically names and scores on top of each other. At least that's how I think about it visually. And then it's like, okay, Alice corresponds to 85, Bob corresponds to 92. And zip is a function that does that, tells the code to iterate like that.
Perfect. Cool. Yeah, this one comes in handy in like ways that I never quite expect. And then I'm like looking at like a piece of sample code like online and they use it. And it's like, oh yeah, that would be really helpful. I never think to use this myself, but it's often used in conjunction with like going through lists and iterating, and you see it a lot in sample code to like kind of pull two lists together and process them and process them together as they interact in some way.
Yeah. Also see it used a lot with the unpacking operator, the asterisk. And that's one thing, it can kind of get confusing to combine the two, because the unpacking operator basically, like, for example, unpacks a list. So in this example, values is a list with 3 elements. And this function func to ABC, that takes 3 distinct elements. So you couldn't just pass values to it because values itself is one list. So that's like one object. But if you unpack it with the asterisk, then it's like, okay, it's separating that list into the 3 elements. So that's how you can pass it into that function in there.
Right. So A would be 1, B would be 2, and C would be 3 in this example. It takes that list and decomposes it. Yeah.
And the way, yeah, sorry, go ahead.
I think like if you zip something and you want to unzip it in the same way, you pass star and your zipped variable and it will unzip it to the original format.
Exactly. Yep. Exactly. Cool. Any other ones that people really like that we should talk about? That they use a lot? Okay, so the second question, which I think Noah presented earlier, was ones that like you haven't used before, didn't know about, but you really want to use. So I have 2 in this list. The first one was that walrus operator. I'd seen a couple like articles and references to this previously, but I didn't actually know it existed. And there's been times, many times in the past, where I wanted to do this. So in C, it's just an equal sign, and you can do this in C all the time. And so as like someone that programmed in C, a couple times in Python, I was like, oh, but I want to assign this, right in my while loop or right on my if statement. And I don't think I can do that in Python. So my first line of code inside the while loop or inside the if statement is, line equals read line strip, but here with the walrus operator, you can not only do the comparison, the equals, and the assignment in one single step. So folks that are used to C where you do this all the time, this is how you do it in Python with that walrus guy. And I had no idea that existed and that was a thing. But this is super popular in some older programming languages if you're familiar with those. And this is the way to do it in Python. So I thought, oh, that's really cool. The other thing that I didn't really know about was the underline thing. So in Python, no, not this underline thing. Not this underline thing. This underline thing. So yeah, it's like basically a throwaway variable. And you can do it using a couple of different ways, but like here, if you're lazy and you feel like I don't want to come up with a name for your variable, you just put an underscore in there and it will loop through on this underscore variable and without assigning it a name. So in this case, in this example, it'll just print hello world 5 times, right? One for the going through the loop in 0, 1, 2, 3, and 4. And print hello world 5 times, but this looping variable never exists. And the other article had some other uses for it too that were kind of neat. I think it was in this one. Maybe it wasn't in this one. Maybe I actually looked for it and found it somewhere else. Yeah, I guess it wasn't in this one. Anyways, this underscore operator I thought was pretty cool to like do a couple things with it. I must have searched on it later because I was like, that's really neat, and found a bunch of other ways to use it too. So yeah, I thought underscore was cool. I didn't know about that. What about you guys? Anything that you saw on this list that was like, oh, I didn't know I could do that?
One thing about that underscore, I think it's like a convention. I don't think the underscore itself is special, but I think it's like that's like just like Pythonic convention is like when you don't need that iterator loop, you can just use that underscore. But I think if like you were to print the underscore in like that example, it would print like 0, 1, 2, 3, 4.
Oh, okay.
Yeah, but it's just like it's just like the Pythonic convention for when you don't need the iterator.
Yeah, you use the underscores too in like when you declare functions that you want hidden. So like, double underscore init, double underscore main,
Right.
and all those like kind of system kind of functions. Underscores used there to kind of set them aside and say this is a special function or
Right.
variable. Anything else, people on this list that people like, I didn't know that existed? That's really cool. I'm going to use that tomorrow. No?
I was
That's all right.
curious
Go
about
ahead.
decorators. I haven't really used those. They seem powerful, but also a little confusing.
Sure. So let's get into like the third question, which Harrison kind of brought up before. So my last question was like, what on this list was like, wow, I don't know that that's a thing, or but I really need to look more into it. So let's do Harrison's question first, then we'll do decorators. So Harrison's question was on shallow and deep copy. So I feel like Noah, you should answer this question because we ran into this problem like about a month or two ago, trying to copy a dictionary.
Yeah, dictionary.
Yeah, so
And some
why don't you
series a lot too.
Yeah, so I'll let you explain the difference between copy and deep copy.
Sure. So a regular copy or a shallow copy, if you use the copy package as copy.copy, or if you do like in this example, if you just said shallow equals original, that's another way to do a shallow copy. And that is basically like, I sort of think of it as you're not really copying the underlying data, you're making a new reference to it. So in this example, you have your original data, you have shallow. Whatever changes you make to shallow will also affect original, because it's referencing the same data like in memory. Whereas if you do deep, which is usually not what people want, right? You want to save your original data and make a copy of it and make some changes and then compare those changes perhaps to the original. And in that case, you would want to use deep copy. So like a deep copy of the original will be what we think of when we think of a copy. Like it's actually it's identical to the original, but it's totally separate. So whatever changes you make to deep won't be reflected in your original. Because it's a different, storing that, it's copying that data into a different place in memory, so it's completely independent. So that's sort of the difference between a shallow copy and a deep copy.
Okay, that makes sense. And I'm often using it like the pandas method, pd.copy or like df.copy, which I think by default is a deep copy.
I think it is as well.
Yeah.
Because like the shallow copy is just like you can basically make, oh yeah, it looks like deep equals true is the default. Yep. So df.copy, yeah, we'll give you a deep copy.
Okay, that's good. Means I haven't been messing up my data.
Yeah.
Yeah.
It's very helpful.
Yep.
Yeah, that definitely was a gotcha in my early days. Like, well, what happened there? It's like, well, you called a function and it touched it.
Yeah. Mm-hmm.
So does that make sense, everybody? Should we do like a really quick example so you can see this in action? Would that be helpful? Because I think this is a really important programming concept, actually, that often gets like hidden away in modern programming languages, but it's super easy to mess up.
I kind of, this is not exactly relevant, but I kind of think of shallow copy and deep copy in terms of pointers, even though it's not the same function.
Yes.
So for shallow copy, I think of it as it's similar to creating a new pointer to the same memory location, but both the original and the new pointer refer to the same data or data frame. But for deep copy, it's kind of like creating a new pointer to a new memory location with a copy of the original data. So changes to the new data don't affect any change or don't affect the original data anymore. I don't know if that's helpful, but that's just how I think about it.
Should we do a quick example, or are people happy with this?
Yeah, I'm just going to say along the same lines, or a variant on that was when you're trying to compare objects. It's like, is this equal to that? It's like, you don't really want to just say, is this equal to that? Because it's like, is it the exact same object? Is the question you can get yourself into asking, rather than saying that you wanted the value of an object or the contents of an object to have equal values. It's a different thing than just saying, you know, if this past object is equal to this other thing. And that you'll get a different answer for shallow versus deep, I believe. Isn't that true? That is a shallow copy the exact same object? If you say, is this equal to that? It is the same object ID.
It is the same object. Yes, that's exactly right.
Yeah, so if you make a deep copy, those comparisons don't work because it says, yeah, it was exactly the same contents, but they're not the same thing anymore. So they're not equal. Unless you're fishing specifically for some characteristic that you call out saying, is this value of the object the same?
I think an example would be great, Pat, to answer your question.
Okay. Here, I'll switch my screen so you can see what I'm doing. Stop sharing that one. Share. This one. Oh, not that one. This one. Yeah. All right. Let me just finish this.
Notebook.
This up. All right, so here's the original code that they had on that example. So I'll run that. That'll semi-initial variable. So original is this list, is this embedded list, or you could array basically. And then here's shallow. It's going to do a shallow copy, and then here's a deep copy. So if I print these out, you'll see that they're the same. They look the same, right? They both have what was in the original 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So on the surface, if you just assign them and print them, you really don't notice the difference. But the difference happens when you start to play around with them. So if I now take and assign shallow and deep to different things, and I'm just going to type a full new array, but you could think of this too, like you could maybe just like add 1 to the list, or like, actually maybe I'll do that. Shallow equals, I think I can do this. And deep equals deep times 2. Oh, actually let me do deep first. When I mess with deep, because it's a deep copy, why didn't I print it? I can't do the times thing. It doesn't like that. Let me do this other. Let me do the other one.
I think it converted that cell block into raw instead of code.
Oh yeah, this one. It did look. It does look like it did that, didn't it? Yeah.
Yeah.
Yeah. Okay. Yeah. So deep, notice when I multiply it by 2, I get like what's supposed to happen with the list. When you do the times 2, it creates a bunch of copies of it. But my original is unchanged, right? So deep, it did a real deep copy. It copied all the original data, made its own object. And so when I can modify deep, nothing happens to the original. But if I do that to the shallow, oh, well, that's interesting. That's not what I expected to happen. Shallow does something different. Maybe just with a simpler one.
Oh, I think that's because you ran that line deep equals deep times 2 twice, Pat. So that's why it's twice as
Oh
long.
yeah, that's why deep did that.
Double
So
long.
why didn't shallow change original on this one? Should have. You're right, I did run deep times 2. That's why I got the double thing. Well, let's try it like this. Yeah, so deep changes deep only, shallow stays the same. If I do this to shallow, it should change shallow, or it should change original too.
I think that's because in this instance, Pat, you're assigning shallow, the name shallow, to a new object.
Instead of
You're
just
not, like,
messing with it.
Instead of just modifying it or messing with it.
Yeah.
Yeah.
So let's see, how can I? Oh, like what if I do? No.
Shallow equals shallow plus 1.
Yeah. Huh. Yeah. This. Huh. Well, hey, what team? I will work on an example with I can show this happens, but I thought this was going to be easy. I really expected so in theory, when you mess with shallow, because you're doing a shallow copy, it should mess with original too, because it's actually the same list, but it's not doing it here. I've definitely had this happen in Pandas when I've like not copied it, when I've not copied a deep one, or when we did dictionaries. Tell you what,
Is there anything about notebooks that would
yeah, I
do it?
know. I'm trying to think maybe it's something a notebook thing. I will work on this, guys, and team, and work out a good example where you can see this because it's not doing what I expect it to be doing. It's funny. Okay, sorry, never mind. I don't have a good example. But what Sharia and Noah, described, that were very good descriptions. That shallow is copying references and deep is actually copying the data. So if you plan on modifying the data later, deep is the way to go, even though it's takes more time and it takes more memory because you're actually creating a totally separate copy. So Noah, you had a question
About
Oh yeah,
decorators.
yeah,
about decorators, yeah.
yeah. I sort of understand like the concept, but the implementation, like line by line, sort of confusing because I haven't built too many classes with Python, so familiar with
Yeah,
the concept, but it's just like what exactly is happening line by line is sort of
yeah.
new to me.
So I gotta be honest, this is one I gotta look at too. This was kind of on my list. So I've never created a decorator like this on my own. So here it's like they're actually creating a decorator and it's doing stuff to it. The place I've used decorators is when I import a, a package that uses them. So one really common way to use decorators is like when you import like something that does GPU operations or like parallel operations or like optimization of math. So like there's uh so like if you want like a function to run its code like on the GPU, like and you're using like um what's that import? It's like NumPy, but it's for GPUs. What's it called? It's skipping my name. Anyways, there's a really cool module you can do or you can import in Python and allows you to run your math code on a GPU. But to designate that you want that code to run on the GPU, not the CPU, you decorate your functions with like that, with like at, let's say I forget what the module is called. Let's say it's called GPU run. So you decorate your method, your function with at GPU run, and that tells Python that everything in that function is supposed to be run on the GPU. So that's where I've really seen it used is when you like want to give Python some additional information about how to execute that function, then you can decorate it and it will tell it to like, execute in parallel or using this package or like on the GPU, something like that. I knew that you can do this, like you can make your own decorator, but I gotta be honest, I have not done this a lot. Anyone familiar with decorators and
Is
use them a bunch?
I just have is it akin to like a Java overloading a class where you basically say this
No,
make your own? No?
it's not. It's a little different than that. But yeah, I thought this was, but yeah, I mean, I've played around with decorators a bit and they are pretty cool. So yeah, like here, real world scenario, this is where I've seen it is use decorators in web frameworks or like in additional modules where you decorate your function and then it tells that module to do something with it. So in this case, it's like managing permissions on the function or telling it to like use a special processing method or maybe like display it to a screen in a certain way. All those kind of things is how I've seen decorators used in like pre-built methods. I don't know if I've ever written one that does it on my own. So this one, it looks like what it does to me, just looking at it quickly, is it tells you how long that function takes. Right.
Right.
So any function then after you define timer decorator, any function after that, it tells you exactly how long that function takes, which is kind of neat. And this wrapper
Yeah.
is a key piece of it, right? So the way to think of decorators is it's wrapping another function around an existing function. So what it does is it takes this function and wraps it around this sleep thing. So it waits till the sleep is done and then executes this code afterwards. But yeah, they're pretty cool. Anything else anyone saw that was like, oh, I didn't know that was a thing. I got to look into that more.
I feel like generators. I wish Harrison was still here. I'd like to kind of talk about generators more because they seem very useful for like large data sets and whatnot. But I'm just sort of having trouble understanding like how the behavior exactly is different from like a regular for loop.
Yeah, so this is a really good description actually. So when you create like a list or something to iterate through, it creates a whole list and shows it in a memory, right? When you use a generator, it's basically creating a list, but it generates the items one by one on the fly and doesn't create a whole list and keep it in memory. So this generator, for instance, will keep creating the next number in a Fibonacci sequence as long as you keep calling the next element of the Fibonacci. The other way to do this, right, is you could say for, I equals 1 to 10 and generate my first 10 Fibonacci numbers, but then all those 10 numbers are in memory. So as your list gets really long, you've set aside a ton of memory to create that list of numbers. But if you have a certain pattern to it and you want to generate in that pattern, you can use this and it doesn't set aside memory for that list. It just keeps calling Fibonacci. It remembers what A and B are as you go through it, and it'll just generate the next number every time you call Fibonacci without taking up any memory except what you need for A and B.
So if you, in this example, if you called Fibonacci 10, n equals 10, so you want to generate 10 elements, would it not return a list of 10? It would just give you the first item first.
It would just give you the I think it would just give you the 10th item.
Oh, okay. That's a 10th item. So if you wanted to create that list of the first 10, you could use like a list comprehension with that Fibonacci function.
Exactly, right. But the purpose of the generator is so that you can have a list and you can keep iterating through with like next without having set aside the memory to do it. Yeah. That's kind of those are the kind of neat. So I know Harrison was doing this with like a list of input values that was like tens or hundreds of thousands of numbers long, and it was really causing some memory problems. So this was a way to do that without having to like worry about creating that whole list of training data and setting aside the memory for it.
Sure. Oh, I see. There's a good example on the Medium post. They also used the Fibonacci sequence with the generator example.
Yeah.
Interesting.
Yeah, so exactly. So to create the list, you actually have to call it 10 times.
Gotcha.
Yeah. Oh, no, maybe not. It's because this makes the list and then it just prints the list. One. Yeah, so I think you're right. No, I think it does create the list of 10 when you call it.
It looks like just running that sample, like if you just in a notebook, if you print fibgen 10 or Fibonacci 10, it's a generator object.
Ah, right. Okay, so you have to use the list
to
like get at it. Yeah.
Yeah, like do the list comprehension to get it.
Okay. Right, like when things return iterators, stuff like that. It just gives the iterator object. Yeah.
So it must be for something like this, if a list of like 10 doesn't seem obvious. I mean, obviously this is an example, but I can see, I guess, how this would be really useful for very large data sets or potentially like an infinite sequence, and you want to get like, you could do like, say you wanted 1,000 Fibonacci numbers, you could pass 1,000 for n, and you could instantly get that generator object. And then if you tried to do that list comp for 1,000, it would be really hard. But if you, I don't know, maybe if you, again, I'm not really sure what I don't know, I'm still trying to think of like a benefit. Like, is it just quicker than if you just did a regular for loop?
Well, if you did a for loop, it would create all those individual items and put them in memory.
Oh, I see.
So it's like a memory storage thing.
Right. Great. So it doesn't actually create those elements in memory until you access them.
Exactly.
The generator.
Exactly.
Okay, I gotcha.
So when
That's
you
neat.
so when you run this line of code, you just get a generator object, which takes up fairly little bit of memory and has this code sitting in it. When you run this line of code, the print line is when it starts to create all the elements of the thing and starts to take up memory, one memory spot for each element.
Right. Wow.
That's kind of a cool memory trick.
Mm-hmm.
Anything else people had a question about? I thought was really cool. It's like I gotta learn more about this. All right, I'm gonna stop recording here.